Good morning, dear students. Today we will discuss about flip-flop conversions. Flip-flop conversions. How many types of flip-flops are there? First, we have to know that one. First one is we have SR flip-flop. Second one is D flip-flop. Third one is JK flip-flop. And fourth one is T flip-flop. So one flip-flop to another flip-flop we have to convert. For that, how many questions are there in this? Means total 12 questions are there. Like SR flip-flop to D flip-flop conversion, SR flip-flop to JK flip-flop conversion, SR flip-flop to T flip-flop conversion. Similarly, D flip-flop to SR flip-flop, fourth question, D flip-flop to JK flip-flop, D flip-flop to T flip-flop, sixth question. JK flip-flop to SR flip-flop, JK flip-flop to D flip-flop, JK flip-flop to T flip-flop, ninth question. T flip-flop to SR flip-flop, 10th one. T flip-flop to D flip-flop, 11th one. T flip-flop to JK flip-flop. Total 12 conversions are there. One flip-flop to another flip-flop. Like that question will be appeared in SR flip-flop to D flip-flop conversion, SR flip-flop to D flip-flop, SR flip-flop to JK flip-flop, SR flip-flop to T flip-flop. Like in this major case, how we have to convert one flip-flop to another flip-flop, I will explain now. Flip-flop conversions. First, I will take one question. I will explain at least 2 to 3 questions in this video. So first, we have to consider how we will convert SR flip-flop to JK flip-flop or any other flip-flops. So SR flip-flop to D flip-flop conversion I will consider first one. So this will be explained in 5 steps, 5 different steps. So we have to take in first step, in step 1, we have to take which flip-flop is available here. Means SR flip-flop to D flip-flop conversion. Means SR is available flip-flop, D is nothing but required flip-flop, required result. So we can take which flip-flop is available here, and you can apply here clock signal. This is the symbol QN bar or outputs. So this is available flip-flop, and we have to convert it into the D flip-flop. For that, here you can design one logic circuit. That logic circuit outputs are S and R. Here input is D. Now this SR flip-flop is converted into D flip-flop. So now in this question we have to find this logic circuit. This is the first step. In step 2, whatever here D flip-flop is there, for original input D flip-flop truth table we have to know. After that, in SR flip-flop, whatever here flip-flop is there, SR flip-flop excitation table we have to know. So truth table already we have discussed in last video, and excitation tables also we have to remember. I will give one shortcut to all excitation tables. So Qn plus 1 you have to consider. This is the present state, this is the next state. Present state and next states are there. These two are present state and next states are there. How the SR flip-flop excitation table will be appeared, how the JK flip-flop excitation table is appeared, how D flip-flop excitation table is appeared, how T flip-flop excitation table will appear. So for this case, here present state and next state 0 0, what is the output? 0 1 1 0 1 1. For these inputs, how the corresponding excitation tables are present. For 0 0, the SR excitation table is 0x, 0 1 1 0 1 0 0 1 1 1 x 0, already discussed in previous video. So now it is from JK flip-flop 0 0, it is 0x, 0 1 means 1x, 1 0 means it is x1 and 1 1 x 0. For D flip flop 0 0 0 0 1 1 1 0 0 1 1 it is 1. For T flip flop 0 0 0 0 1 1 1 0 1 1 1 it will be 0. This is the step 2. Means I am writing here all flip flop excitation table. You have to write enough for SR only. Whatever the flip flop is available, that flip flop you have to write here. Step 3, we have to write here transition table. Transition table, or we will call this is the implementation table. It will have original flip flop D, and here Qn is present state, Qn plus 1 is next state. After that, flip flop inputs. Flip flop inputs are S and R are there. S and R are there. So using truth table, we have to fill up to this part, D flip flop part. Using excitation table, you have to fill this SR inputs, flip flop inputs. So when the D is 0, using truth table, when the D is 0, present state is 0 or 1, what happened? This is nothing but reset condition. When D is 0, present state is either 0 or 1. When D is 1, present state is either 0 or 1. This is called set condition. First in D flip flop, first one is reset mode, second one is set mode. So using excitation table, here Qn is there, Qn plus 1 is there. 0 0, that is 0 x. 1 0, 1 0 is there. 0 1, 0 1 is there. 1 0, 1 1 is there. 0 x. So now in step 4, we have to discuss Kmaps for outputs. Here outputs is nothing but flip flop inputs. One is S, another one is R. Here two variables are there. So two variable Kmap we have to draw for S, that is inputs are D, Qn. This is the D bar, D, Qn bar, Qn. This is for D, S output you have to fill this one here. 0, 0, 1, 0. So only isolated pair is there. S is equal D Qn bar. D Qn bar we have to write. Next, similarly we have to take the two variable Kmap for R output also. So here D Qn, this is for R, D bar, D, Qn bar, Qn. This is for R output. So R output means you can fill this one. R output x 1 0 x. You have to take either this one or this one. Whatever it is there, you can take no problem. So whenever we are taking this one pair, means R is equal to Qn. R is equal Qn. Whenever you are taking this pair, R is equal D bar. A తీసుకున్న problem లేదు. Finally, last step we have to discuss its logic circuit. Last step we have to discuss its logic circuit. That is step 5, logic circuit based on outputs. So here S is equal, already we are derived from Kmap D Qn bar. R is equal here Qn. After getting this one, your original available flip flop is S and R. It will have clock signal here Qn bar. Now here in S place, that logic will be D dot Qn bar. So this is one AND gate. It will have one input is D, another input is Qn bar. So here R case, it will be connected to the Qn. You can leave like this. Otherwise, you can connect here Qn bar is there. From here, you can connect here Qn bar. Qn is there. From here, you can consider Qn. This is the answer for SR flip-flop to D flip-flop conversion. One more conversion I will explain here. Now D flip-flop to T flip-flop conversion. D flip-flop to T flip-flop conversion. So like similarly in step 1, which flip-flop is available? D flip-flop is available. We have to convert into T flip-flop. So you can consider D flip-flop. D is the input. Here clock signal Qn and Qn bar are outputs. So here some logic circuit is there. Some logic circuit. After that this input is connected to the T. T is nothing but D flip-flop is available flip-flop. We have to convert into T. So for this logic we have to find. So in step 2 we have to take T flip-flop truth table, and D flip-flop excitation table. In step 3 I am taking directly transient table. In this transient table, here original input is T and present state is Qn. Next state is Qn plus 1. And flip-flop input is D. So this is the original input. This is the flip-flop input. So using truth table we have to fill this one. Using excitation table fill this one. Excitation table use chesi deenni fill cheyandi. So when the T input is 0, either present state is 0 or 1. When T input is 0, present state is 0 or 1. No change condition. When T input is 1, present state is either 0 or 1. Toggle condition. 0 unte 1, 1 unte 0. Dini toggle condition antam. So using excitation table 0, 0, you can consider two variable Kmap. That inputs are T and Qn. This is the T bar, T, Qn bar, Qn. You can fill for D కోసం flip చేస్తున్నాం. D ని దీన్ని తీసుకెళ్ళి దీనిలో సబ్స్టిట్యూట్ చేయండి. 0, 1, 1, 0. These two are isolated pairs. So D is equal here T bar. This is the Qn. T bar Qn plus T Qn. So here D is equal T bar Qn plus T Qn bar. Finally using this one we will draw logic circuit. Original logic circuit is D flip-flop, this one. So here T Qn bar, in this one AND gate is there, that inputs are T bar Qn. Another one is T Qn bar, another AND gate. In between plus sign is there. Plus sign means OR gate. That OR gate output is connected to the D flip-flop. Like you can do remaining conversions, one flip-flop to another flip-flop conversion. In some cases 3 variable Kmap will be appeared. In some cases 2 variable S, R, J, K appeared. 3 variable Kmap required for solving output equations. So based on that transient table you can take either 2 variable or 3 variable Kmap. You can simplify that one. You can draw logic circuit. This is the very most important topic. Everyone do remaining problems. If any doubts, message me. I will make another video. Thank you all.